Every day, new cryptocurrencies are coming into existence, and with them, new blockchains. The idea that one or few blockchains would rule and cater to all use cases is proving to be impractical. A much more likely future is many smaller blockchains built for specific use cases and specific user bases. But this introduces a new problem. Value is getting locked into disconnected silos. There are two aspects of the problem: lack of information flow and lack of value flow. Try to think about this problem as there are many financial organizations who cannot communicate with each other or transfer funds among themselves. It is like you cannot transfer funds from your bank to someone who has account with another bank. Or you cannot take loan against your assets deposited with another bank, or cannot buy financial assets from another bank than your bank. In the case of traditional finance, central banks guarantee cross-institutional communication and fund transfers. In case of blockchain and DeFi, there are no central authorities like that. Yes, some intermediary can be used to create swaps or issue wrapped coins, but that approach fundamentally defeats the purpose of decentralized finance. This is where cross-chain interoperability comes into play. Cross-chain is a technology that enhances interconnection between blockchain networks by allowing transfer of information and funds. Now let us talk about some use cases of cross-chain interoperability. Some use cases are portable assets, cross-chain atomic swaps, cross-chain oracles, asset encumbrance, and general cross-chain contracts. Portable assets involve moving a crypto coin or token from one blockchain to another securely, trading it, or use it for collateral. Sometimes also known as atomic swap, a cross-chain swap is a complete decentralized mechanism of exchanging tokens for other non-native ones without the need of an escrow or a middleman. Cross-chain swaps are performed through special smart contracts that can handle both types of tokens. Now coming to cross-chain oracles. Cross-chain oracles allow smart contract in one chain to perform some activity when it receives information from another chain. Now coming to asset encumbrance, it is about locking up asset in one chain where the locking conditions are dependent on activity on another chain. Now, general cross-chain contracts. For example, paying dividends on one chain to holders of an asset whose ownership is registered on another chain. So how can we achieve cross-chain interoperability? As per a paper by Vitalik Buterin, there are three ways to achieve cross-chain interoperability: centralized or multi-signature notary schemes, side chains or relays, and hash locking. We are not going into the details of these methods because these are too technical. Rather, let us talk about some examples of cross-chain interoperability. One of the earlier cross-chain interoperability projects was BTC Relay, a smart contract on Ethereum that can read the Bitcoin chain. The interoperability is one way. Bitcoin cannot read the Ethereum chain, as its scripting language is not sophisticated enough to do so. We have some more sophisticated cross-chain interoperability projects now: Cosmos, Polkadot, Blocknet, Harmony, Fusion, AnySwap, Rain, and OneChain. Let us talk about some of these projects. Let us start with the Cosmos network. The end goal of Cosmos is to create an internet of blockchains, a network of blockchains able to communicate with each other in a decentralized way. How? Let us understand the Cosmos architecture a little bit to understand that. Three fundamental building blocks of the Cosmos network are Tendermint BFT Engine, the Cosmos SDK, and IBC. Let us start with Tendermint BFT Engine. Now, from architectural standpoint, blockchains have three layers. Application layer, that is responsible for processing transactions, networking layer, that is responsible for propagation of transactions and consensus related messages, and consensus layer, that is responsible for enabling nodes to agree on the current state of the system. Building a standalone blockchain requires building all three layers from the ground up. Tendermint BFT is a solution that packages the networking and consensus layers of a blockchain into a generic engine, allowing developers to focus on application development. BFT stands for Byzantine Fault Tolerance, which is the consensus algorithm used within the Tendermint BFT engine. The Tendermint BFT engine is connected to the application by a socket protocol called the Application Blockchain Interface (ABCI). The protocol can be wrapped in any programming language, making it possible for developers to choose a language that fits their needs. Some defining features of Tendermint BFT are: it enables creation of both public and private blockchains. It can have a block time on order of 1 second, can handle up to thousands of transactions per second, and offers instant finality with higher security. Now let us talk about Cosmos SDK. The Cosmos SDK is a generalized framework that simplifies the process of building secure blockchain applications on top of Tendermint BFT. It is based on two major principles: modularity and capabilities-based security. The goal of the Cosmos SDK is to create an ecosystem of modules that allow developers to easily spin up application-specific blockchains without having to code each bit of functionality of their application from scratch. The Cosmos SDK also comes with a set of useful developer tools for building command line interfaces, REST servers, and a variety of other commonly used utility libraries. Now coming to IBC, Inter-Blockchain Communication Protocol. IBC plays the major role in cross-chain interoperability in Cosmos. Through IBC, the connection between the blockchains is achieved. IBC allows heterogeneous chains to transfer value and data between each other. Now the Cosmos ecosystem is built on top of Tendermint Core and consists of two parts: hubs and zones. A hub is the central Cosmos blockchain built on top of the Tendermint Core. Zones are autonomous and independent blockchains that are connected to hubs. The independent zones can be launched and connected to any external blockchain network like EOS or Ethereum, etc. All the communication between hubs and zones happen through the common IBC protocol. Each external blockchain needs a separate zone to connect with the hub. The hub also acts as a decentralized exchange, and all the tokens or coins are converted via atomic swaps, which brings massive liquidity across the network. The Cosmos blockchain has its own native token called Atom. The Atom token is used as collateral for all the nodes participating in the POS consensus. If any POS node comes under the radar of malicious activity, staked Atom tokens are burnt and the participating nodes are removed from the network. Atom currently has a market cap of more than $5.6 billion. Now let us talk about the Fusion network. The Fusion network touts itself as an all-inclusive blockchain-based financial platform that offers cross-chain, cross-organization, and cross-data source services through smart contracts. Fusion uses a custodial model for interoperability, but not centralized custody. Fusion uses a decentralized custodial technology called Distributed Control Rights Management, or DCRM. DCRM is basically the distributed storage of private keys across the network of nodes using sharding. In the traditional custodial model, the keys are held on a centralized server, which increases the chance of them being compromised. In DCRM, however, keys are not held on a central server but are divided into fragments called shards, encrypted and distributed across the global network. The decentralized custodial model holds and transfers assets on behalf of the user across heterogeneous chains and also allows cross-chain and cross-system interoperability. Fusion has built a suite of different products that offer interoperability along with a set of finance-related APIs, which allow the developers to build their own financial applications that can cross-communicate with any of the supported blockchain protocols. Now, Fusion uses a new kind of consensus mechanism called ticketed proof of stake, which is a custom-built consensus engine to secure transactions on the Fusion network. FSN is the native coin of Fusion network and enables access to entire suite of features and financial transactions on the network. In the case of ticketed proof of stake, an owner of 5,000 FSN may purchase a ticket for a chance to sign a block with their anonymous node. Currently, FSN has a market cap of $53 million. Now, apart from these, there are many other promising cross-chain interoperability solutions such as Polkadot, Blocknet, Harmony, AnySwap, Ren, and OneChain. Big picture now. What do you think will be the structure of the DeFi ecosystem in future? One or two major versatile networks like Ethereum, or many small application-specific networks catering to specific problems and specific user bases. In the first case, scaling solutions will be critical. And in the second case, the cross-chain interoperability protocols will become major networks. With this is Sam Ghosh. Thank you very much for watching. Bye-bye.